Let's discuss this question. The work function of caesium is 2.14 electron volt. Find the threshold frequency for caesium and the wavelength of the incident light if the photocurrent is brought to zero by a stopping potential of 0.60 volt. It's given that work function is 2.14 electron volt. The symbol for work function is phi naught. Phi naught is equal to 2.14 electron volt. And we are asked to find the threshold frequency. The symbol for threshold frequency is nu naught. And also we are asked to find the wavelength of the incident light, that is lambda. And additionally they have given the stopping potential is 0.60 volt. Stopping potential should be taken as V naught. V naught is equal to 0.60 volt. Let's calculate what is nu naught first. So how will you calculate nu naught? We know the formula for work function is phi naught is equal to h nu naught. And from this, we can write nu naught is equal to phi naught by h. What is phi naught? It is in electron volt. You have to convert it into joule. So 2.14 into, what is 1 electron? The charge of 1 electron is 1.6 into 10 power minus 19. So you can also remember this as when you are converting electron volt to joule, you have to multiply by 1.6 into 10 power minus 19. And the answer for the product of 2.14 and 1.6 is 3.424 into 10 power minus 19 joule. Now let's apply that phi naught value here. 3.424 into 10 power minus 19 divided by h value is 6.626 into 10 power minus 34. And what is the answer for 3.424 by 6.626? So you can just take that 3.424 to its nearest number, 3.4 by 6.6 into 10 power minus 19 plus 34. And its answer is plus 15. 3.4 by 6.6 is 0.51. So we can write nu naught is equal to 0.51 into 10 power 15. And it can be written as 5.1 into 10 power 14 Hertz. So this is how we can calculate the threshold frequency. Next, we are asked to find the lambda. So how to find lambda? By Einstein's photoelectric equation, phi is equal to phi naught plus kinetic energy. And you know, they have given the potential. So you have to take the formula for kinetic energy as EV naught. So phi naught plus EV naught. And you know the value of phi naught in electron volt also. Just check that value. 2.14 electron volt plus E into, what is V naught value? 0.60. And now you can calculate the total energy of incident light in terms of electron volt. 2.14 plus 0.60 is 2.74 electron volt. Now we can convert 2.74 electron volt to joule. 2.74 into 1.6 into 10 power minus 19. And the answer for this multiplication is 4.384 into 10 power minus 19 joule. So now we have calculated what is phi naught in joule. But the aim of our question is to find the wavelength. So let's calculate the wavelength. We know that phi is equal to h nu and nu is equal to hc by lambda. Therefore, phi is equal to hc by lambda. Lambda is equal to hc by phi. H is 6.626 into 10 power minus 34 and the c value is 3 into 10 power 8 divided by phi value in joule we have calculated as 4.384 into 10 power minus 19. The product of 6.626 into 3 is 19.87 into 10 power minus 26 divided by 4.384 into 10 power minus 19. To make the calculation simpler, let's take the numerator to the nearest whole number, that is 20, and the denominator is 4.384. and it can be approximated as 4.4, and the total power is 10 power minus 7. The final answer is 20 by 4.4 is 4.5454 into 10 power minus 7. Can be written as 454.5 into 10 power minus 9 meter. The unit of wavelength is meter. So finally, we can write this as 454.5 nanometer. So this is how we have calculated the wavelength as well as the threshold frequency for this question.